setting the present working directory to our package, and then initiating SLE command, and then starting with the new model. So it gives the library with a canvas. In this session, we'll be seeing how to append a single line diagram for a single machine connected to infinite bus. Let's start the process with a generator block first, a bus, and then a transmission line. So in the earlier sessions, we have already seen how to enter the data and adjust the blocks. And resizing the bus as desired. So according to the problem statement, we require 3 buses. And as discussed in the earlier sessions, a generator block accompanies other 3 additional blocks. So these are excitation system, turbine, and PSS. Whose state of operation can be controlled with the generator block itself. Let's place the excitation block and the turbine and then the PSS. So let's start entering the data for excitation system, again as defined in the problem statement there. So we are initializing the parameters associated with a given block. The excitation block has been filled, same with the PSS block, and same with the turbine block as well. And now comes the generator block parameters. So here we are accompanying a 2.2 model of a synchronous generator. So direct axis and quadrature axis parameters we have to initialize. These are the reactances and the open circuit time constant. And here we go for XQ double dash, and same with the open circuit time constant. And now for the inertia and the damping factor, referring the problem statement again. For initializing the terminal voltage as 1 per unit, we'll directly initialize there. And then for enabling or disabling of AVR, turbine, and PSS, we'll write there 1. And again verifying or having a walkthrough to the entered parameters. There we go. So the values are entered there. So we can start with the connections of single line diagram. There we go. And duplicating a line again. Again, initializing the parameters as displayed or given in the problem statement. Same with the line 2 as well. Now for making an infinite bus system, we'll be connecting it to a generator which will be robust. Robust in the sense its inertia constant will be very large, and the parameters, the Q-axis and D-axis parameters will be very negligible in comparison. So that it can maintain the terminal voltage and the frequency almost constant there. And then for having a syncing capability for the load or for the infinite bus, we'll be adding a load block there. And we have already seen how to append this diagram before in the earlier sessions. So again, with the generator block, we'll be assigning the d-axis and q-axis parameters, but now it's for an infinite generator, infinite bus. So initializing these parameters there with negligible d-axis and q-axis parameters. And then a very large inertia constant. So let's take as 10,000. And then voltage as 1 per unit and power supply or power input to the bus as 0. And we'll be defining this generator or this bus as PV. So proceeding further. So as done earlier or as discussed earlier, we'll be having 3 additional blocks for each generator block. So let's drag them there. And rotating using Control R. There we have. And editing the parameters again as discussed earlier. That is, the outer string should correspond to the bus number which it is connected to. So bus number 3. And same with the excitation system bus number 3. With the PSS block as well. So let's save the file as a SMIB system or SMIB sys. There we have with .mdl extension. So let's try extracting the values with .mdl and displaying the data matrix first. So purposely we have kept some error in the diagram. So let's see how the program will notify that. Yes, there we have. So first let's toggle this error such that it doesn't pop later on. So dragging the common data display. And initializing the frequency as 50 Hz and leaving or modifying the parameters as desired. And then again saving it and again trying to extract. The bus 2 and bus 3 numbers, bus numbers are wrongly set to 1. It's giving that error. So let's rectify it. So step-by-step process to remove any kind of error. There we have. So we have the data of the single line diagram assigned to specific variables as data matrices and a no error flag. So now we can create the data file folder. And if you concentrate at the left bottom of the page, a folder of the same name is created there. So let's initialize the load flow analysis, which we have already seen. and same with the bus variables. There we go.